Assalamu alaikum students. I hope that you all are fine. In this video lecture, I am going to discuss about Valence Bond Theory. Valence Bond Theory is also known as VBT. According to VBT, the atomic orbitals of combining atoms, these orbitals should be valence orbitals. They should be half filled. These orbitals should be valenced, they should be half filled, and they should have electrons with opposite spin. If any atoms has atomic orbitals, valence atomic orbitals, and follows these three conditions, they should make bond according to VBT. According to VBT, when atomic orbitals are half filled and these electrons are having opposite spins, they can make covalent bond. These atomic orbitals will overlap to form covalent bond. Now, how they can overlap to each other? There are two ways for their overlapping. First is they can overlap head to head, forming sigma bond. And second condition, they can overlap side by side, forming pi bond. Now, what is the difference between sigma and pi bond? According to sigma bond, in this case, atomic orbitals overlap by head to head. When atomic orbitals overlap head to head, they form sigma bond. In this case, electronic density is in between two nuclei. In this case, electronic density is in between two nuclei, and sigma bond is the first bond that is formed when two atoms make bond, and it is formed in between s and s orbital. It can be formed in between s and p atomic orbital, and this p can be x, can be y, can be z. Px is the atomic orbitals that is oriented along x-axis, and y is oriented along y-axis, and z is along z-axis. In this case, when atomic orbitals overlap by side, when atomic orbitals overlap side by side or parallel to each other, they form pi bond. In this case, electronic density is present above or below the bond axis. In this case, electronic density is present above or below the bond axis, and pi bond are formed in between py and py atomic orbital, or pz and pz atomic orbital. Now, examples of sigma bond: when px atomic orbital overlap with another px atomic orbital. Here are the two lobes of p orbital. In next diagram, there will be the overlapping in between these two atomic orbitals. Now you can see that this is head-to-head overlapping, and here is the electronic density. Electronic density. We can say that electrons are tightly bounded in between these two nuclei. Here is the one nuclei and second nucleus is here. Positive charge attracts the negative charge tightly, and these electrons are bounded. And this thing makes sigma bond inert, less reactive. Due to this condition, sigma bonds are inert, inertness, or least reactive. No electron loving CBG can reach on these electrons, and electrons are present on the bond axis. Here is the bond axis. Now in case of pi bond, py orbital, it's py and it's px. Py orbital overlap with another py orbital. Now you can clearly see that this part of these orbitals is being overlapped to each other, and here is the bond axis, and electronic density is present on or above the bond axis or below the bond axis, and any electron loving CBG can reach on these electrons. So we can say that sigma bond is inert and pi bond is reactive. Or in other words, we can say that in case of sigma bond, it is a strong bond and pi bond is the weak bond. According to VBT, the combining atoms should have valence shell, valence orbital having half-filled electrons, and these electrons should have opposite spin. And such type of orbitals will overlap to form covalent bond. And this overlapping has two ways. First is head-to-head overlap forming sigma bond, and second is side-by-side overlap forming pi bond. Now going to discuss few examples according to VBT. First example is hydrogen molecule, H2 molecule. Before going to discussion of the molecules, VBT tells us about the bond length. It tells us about the formation of bond and bond energies, and it also tells us about the shape of a molecule. And these are few things that we can find according to VBT. Now hydrogen molecule. We know that hydrogen has one electron in its valence shell. Its electronic configuration is 1s1, and second hydrogen atom also has 1s1. Now it's 1s1. and it's also one as 1. You can see that I have drawn the electrons with opposite spin. First is either clockwise or anti-clockwise. We can write that electron with respect to other one. Now this s electron will overlap with second s orbital and form hydrogen molecule, forming single bond. Now what will be the diagram for hydrogen molecule? Here is one s and it's going to overlap with another one s, and here is the molecule of hydrogen atom, and here is the overlapping in between these two s orbitals, S2. Now next example is wait. Now second example is F2 fluorine molecule, and we can explain the fluorine molecule on the basis of VBT. We know that fluorine has 9 electrons in its shells F2. In this 2 fluorine form single bond. First fluorine has electronic configuration 1s2, 2s2, 2px, 2py, and 2pz. Now you can calculate the number of electrons. There are 9 electrons in these orbitals. You can keep 2pz as unpaired atomic orbital or px. Second fluorine should have such electronic configuration. Now their diagram are, first of all, their bonding, drawing their block form. These are the atomic orbitals, valence atomic orbitals. First S has 2 electrons, second S also has 2 electrons, and 2px has 1 electron, 2py has 2, and 2pz has 2 electrons. Second fluorine molecule has same electronic configuration. Here are 2 electrons, 1 electron, 2 electron, and 2 electron. Now 2px has electronic configuration unpaired electron, and these electrons are oppositely spin, and these 2px atomic orbital will overlap to form single covalent bond. Now its diagram: 2px is the atomic orbital oriented along x-axis. Here is 2py and here is 2pz. 2px has 1 electron, 2py has 2 electron, and 2pz also has 2 electron. It's one fluorine atom. Now second fluorine atom, its second fluorine atom, px orbital, it's px, I should mention it, px, it's py, and it's pz. it is also px. Second py atomic orbital and pz atomic orbital. Px has one electron. We know that the bond is formed in between those atoms where two electrons exist. So here two electrons are existing in between one fluorine atom and second fluorine atom, so bond is formed. Here are two electrons and here are also two electrons. If you have any question regarding fluorine molecule, you can ask in comment. I have written unpaired electron on px for my own easiness. We can also write 2pz as unpaired electron. Then the formation of the molecule or its structure will be the same, but it should be overlapping in between 2pz and 2pz atomic orbital. Now one example from double bond, that's oxygen molecule. Oxygen molecule, how a double bond can form in between two atoms. In case of oxygen molecule, we know that oxygen forms double bond with another oxygen atom, and oxygen has eight electron. We can write its electronic configuration 1s2, 2s2, 2px, 2py, 2pz. Here are two electrons, here is one and one electron. Now second oxygen should have the same electronic configuration. I am going to show their overlapping in between these two oxygen atoms. Its electronic configuration of first oxygen atom, and it is for second oxygen atom. One s2 has two electrons. 2s2 also has two electrons. 2px has one electron, 2py also has one electron, and 2pz has two electrons. Now in these orbitals, I should write the opposite spins of these electrons, and here are two electrons. Now naming these orbitals, it's 1s, it's 2s, it's 2px, it's 2py, and it's 2pz. 2px and 2py will overlap to each other, forming double bond. First overlap in between 2px and 2px will form sigma bond, and second overlap in between 2py and other 2py will leads to pi bond. Now its diagram, here is 2px orbital, it's 2py, and it's 2pz of one oxygen atom. 2px has one electron, 2py also has one electron, and it's 2py, and 2pz has two electrons. Now second oxygen atom is 2px, 2py, and 2pz. 2px has one electron, bond is formed, and it's a head-to-head overlap in between 2px atomic orbital, and here is 2py with opposite spin, and 2pz have 2 electrons. It's 2py. Now we can show side by side overlapping in between 2py. It's side by side overlapping. And we can say that it's a side by side overlapping, so it's a pi bond. It's pi bond, it's one oxygen atom and its second oxygen atom. So we can say that oxygen molecule has one sigma and one pi bond. Oxygen forms one sigma and one pi bond. Here is one sigma and one pi bond. If you have any question regarding oxygen molecule, you can also comment in comment section. Next, one example from triple bond, and that's nitrogen atom, nitrogen molecule. How nitrogen molecule forms triple bond? Going to third example of triple bond. It's nitrogen molecule N2. Nitrogen forms triple bond with another nitrogen atom. We know that nitrogen has 7 electron, and their electronic configuration is 1s2, 2s2, 2px1, 2py1, and 2pz1. Now you can see that the valence orbital has 3 unpaired electrons. So nitrogen has capability to form 3 bond or triple bond. Now their overlapping form, it's atomic orbitals of one nitrogen atom, and here is the atomic orbitals of second nitrogen atom. 2 electron in first s, 2 electron in second s, 1 electron and 1. In this case, there should be opposite spin of the electrons that are going to overlap for covalent bond. Now this px will overlap with another px, this py will overlap with another py, and this pz will overlap with another pz. Now its diagram, px is the orbital which is oriented along x-axis. It's px atomic orbital of one nitrogen atom. It's py atomic orbital of another the same nitrogen atom, and it's pz of the same nitrogen atom. Now putting electrons in these orbitals, here is 1 electron, and 1 electron. Second nitrogen atom also have the same shape. Here is px, py, and pz. Now putting electronic configuration in these orbitals, 1 electron, 1 and 1 electron. It is understood that px is overlapping with another px, forming sigma bond. Then we can write here that it's sigma bond in between these two orbitals. Here is side by side overlapping in between 2py and another 2py, and here is also side by side overlapping in between 2pz and another 2pz. Here is also pi bond and another pi bond. We can write that nitrogen atom forms triple bond with another nitrogen atom, and in this 3 bonds are present, and first bond is sigma, second is pi, and third is also pi bond. We have studied in this video lecture that the bonding atoms should have half-filled valence orbitals, and those valence orbitals overlap to each other by 2 ways. First are head-to-head and second are side-by-side. If they overlap head-to-head, they form sigma bond, and if they overlap side-by-side, they form pi bond. VBT has limited applications, and its advancements are explained in hybridization. You can also search a video lecture on hybridization. If you have any question regarding these topics, you can ask in comment. Thank you, and don't forget to subscribe my YouTube channel and share my videos to others. Thank you, and Allah Hafiz.